and thank you for joining us, all the young talent that came in after a lecture. I'm delighted to introduce the next speaker, Mr. Brian Womble, that I got to know yesterday. He's currently the Deputy Director of Open Architecture at the US Navy. So wholeheartedly welcome to the US Navy. It turned out that Brian and I had quite a lot of things in common. We've been crossing paths at Ericsson, Alcatel. He's been at Cisco, at Lockheed Martin, and many other organizations. He claims he never planned to work for the government, but now he's working for the government. Now I can say that this government is a little special, the US Navy, because they're into something that I never thought they would go into, namely open architecture. So with that said, we leave it to you. I brought some of the MARSEC team here, Zach Borsch, Alan Grech, Annalisa Abdillah, to see if we can ask you some difficult questions at the end. So we'll see. Okay, it's all yours.
These are my bodyguards?
That's right, exactly. So it's all yours.
Okay, I'm going to use the other microphone. First, I want to comment about the venue. What an amazing place. This country that you guys have inhabited, can I come too? It's beautiful. The other thing I want to mention is you've got a couple of very smart people up here, and I want to talk a little bit about art, because what a smart thing to do is to set this venue in terms of art, because when you develop systems, you need art. You need to generate the kind of thinking that builds systems in a way that they're long-lived. They have character, they have meaning, and they provide the user with the experience that he or her, she or him, are looking for, right? So it turns out in every one of us, we've got two parts to our brain. One of them is this thing called the lizard brain, and we're all born with it. And I'm up here kind of fighting the lizard right now. And the lizard is this piece of your brain that says, be afraid, don't change, argue when people try to make things different, be careful what you're going to do. Don't talk up in a meeting if you know something, but because you don't want to insult someone. That may not be the best path sometimes. I mean, if you're going to be an innovator, you need to think more like someone who I guess the Romans called it the daemon. The daemon is another D-A-E-M-O-N. And this is also known, the Romans also called this second part of your brain the genius. And this is the part of you that wakes up in the morning and has a great idea and acts on it, does something, delivers. Because it's one thing to say we're going to innovate. It's another thing to do it. And I was talking to Gear last night, and we were talking through the people we know at Ericsson. We were talking about some of the patterns of behavior that we're going through, and he started talking about some of the tools he'd worked on. This guy built a lot of the tools that I was working on in Ericsson Network Systems in Dallas. I had no idea. And he knew all the guys that I knew, and he knew all the special people that made a big deal in my life. I mean, really formed a lot of my thinking about how we're going to build stuff for the future. So I don't know how these people ended up here with you, but you're lucky here in Malta to have them. And I warn you that if you're in industry and you're looking at this effort that we're going through, something's going to be delivered, and you better be on board with it, because this guy knows how to innovate, and so does this lady. So let's keep going. Okay. Is this working? Oh, there we go. Why am I here? Okay. It turns out that the one thing in this world that we can do to improve ourselves is commerce. In fact, I would submit to you that we're sitting on top of the solution to world peace. If we want this world to be at peace and we want to get out of all these wars, we need to make everyone economically successful. And it doesn't make any sense for any country to sit back and think that they have everything in one basket. So the United States is committed to helping you become our competitor, because only through competition will we get better. It's the genesis of innovation. Forward, backwards. Okay, there it is. Spreading competition. Spreading knowledge advances competition. We want everyone in the world to participate. I'm going to go quick on this because I'm running out of time already. I can feel it. Okay. This industry that we're working with, it seems kind of funny. Why would the Navy want to come over and talk to an industry that's really about the top tier of our economic wealth in the world? Well, it turns out those same people are the people who have the power to generate innovation through their investment, through their commitment, by leading the world in new economic development. The other thing is my boss was actually the guy who was invited. At the last minute, his boss pulled him off and said, got to send somebody else, so I lucked out. This has a little delay in it, I think. Maybe I need some help. There it is. Let's talk about passion. So when I was a kid, we didn't really have computers, okay? This guy on the top left was named Mike Nelson. There was a show called Sea Hunt. Did anybody ever see it? Yeah, okay, it was cool because for the first time in my life, somebody could go into another, place with this air thing on and explore underwater. And there were things like, buried or treasure chests. There were these huge fish. There was a guy there snorkeling. I mean, he was, just a freelancer, but it was a freedom that I just couldn't believe. And so the other things we had like Superman and Batman, but they were kind of weird. They were kind of outside the scope of where I could go. So here I am. My dream was to get in the lake, get in the water, and get some fish, right? So these fish, they were huge. These are called buffalo carp, and I'm in a place called Possum Kingdom Lake in Texas. And once a year, they have something called a buffalo run. And so what would happen is you'd get in the water, and you'd go down about 10 or 15 feet, and all of a sudden these fish would start hitting you with their mouth. It was real scary because they're knocking your regulator loose, and you didn't know what was going to happen next. And if you got real still, they'd stop hitting you, and you'd see them come by. And what they were trying to do, their pattern was to go into a female fish and knock her in the stomach and knock the eggs out. Well, right after they do that, the males all die. So what we would do is we'd spearfish these things. They were legal to spearfish. Then we'd take them back to a place in Fort Worth where there were some people who knew how to smoke them, and they really had a great time because we had over 300 pounds of fish on this trip. So here's a place called Hell's Gate. And I wanted to put it in there because I looked at some of the pictures of Malta, and I thought, I've kind of seen some of these things before. This is on a lake, but it's amazing how beautiful it is here, and I thought that was a good kind of way to branch off. Okay, here we go. My background. My first job was a snow cone vendor. I made 3 cents per snow cone. Second job, let's see. Oops. Second job, I was a lifeguard. That's where I got to use the scuba stuff. After that, I went into working in an underwater show. We were talking about that last night, so I got to do scuba dive some more. And then I got to I got into welding in a place where they did oil rigs. Okay, and I was the guy who put the seals on the bottom of the oil rig. These things were huge. And so I kind of got into engineering. I kind of started thinking that way. Okay, so now I'm going to talk about what I'm here to talk about, MFOP. Now, everybody else was using acronyms, and no one knew what it was. Yes, sir? A little closer? Okay, sorry. Can everybody hear me? Maintenance-free operating period. What does that have to do with anything you're doing? Well, maintenance-free operating period, and we're going to talk about it. Could it improve your profits? Could it improve your market share? This is one way to change the way systems are built and improve their behavior. So we're going to talk about that. Okay, OA, MFOP, evolution. Open architecture, when I joined the military industrial complex, it was about 2001. I'd just been laid off from Cisco. And I joined a team in Manassas, Virginia, working on submarines. And the submarines had just come through a very scary time in that the Soviets had figured out a way to build systems that could detect our submarines. And our sonar systems were behind. We didn't have the ability to detect them. So we needed a new model. And there were several people involved that had a great idea, and they said, why don't we try this open architecture thing? So the genesis for that was the Navy cut the budget by half. Okay? So now the program was sink or swim. Either make it or don't make it. So immediately behavior started to change. There was no choice. And when I got there, we were attempting to get the first delivery out. It was called TIOO, which stands for Tech Insertion 00, or 10. So it was the first version, and they'd been working for about 6 years on the project. They still hadn't delivered the first one. It was an exciting time because within 2 years, we had the first version of TIOO out, and now we're working on TIO2 because every 2 years we generate a new system. And this created an environment which had never been done before in the U.S. Navy, because normally what we would do is build a system that was perhaps destined to stay on the ship for 23 years. Very frustrating in a technological environment where motherboards are maybe only produced for 3 months, right? So now we're using COTS, commercial off-the-shelf equipment. We're replacing the military standard stuff. We're changing it out every 2 years. And this produced an amazing improvement in technology. We threw out all the old code. We grabbed some of the algorithms in the sonars and the radars and all the different systems that are on board. We packaged them in new computer languages, the forward-thinking computer languages. We got out of using military-specific operating systems. We abandoned all that stuff. We joined the mainstream of development, okay? And that's where I'd come from, because I'd been a developer at Ericsson. I'd worked at Alcatel. I'd kind of been in the mainstream of what was going on, and at Cisco. So this created a great opportunity for the Navy to advance where we were. And actually, we could drop new algorithms into the sonar and test them out within a year, which was unheard of at the time. Well, the problem we had, we started noticing that our systems weren't quite as robust as they used to be. In fact, one day I was standing there and there was this great noise, and then what it was, the system was rebooting. And I turned to the guy next to me and I said, "Did you hear that?" And he goes, "Oh yeah, that happens all the time." And I said, "Wait a minute. I'm a submariner," which I wasn't, but I'm sitting on the bottom of the ocean and I'm listening. And there's a bad guy above me, and I get the feeling he just found me. And I reach and I touch a button. Now I've got to wait 10, 15, 30 minutes before I can shoot a weapon. What the hell am I going to do? We can't have this. This is impossible, right? I mean, you can't have a system where you have 130 sailors, depending on their lives, and the system is down. Does this sound like something on a pleasure ship? The storm's blowing in, and all of a sudden your engines can't go? Or you can't use your radio? Or some other system on board that's critical to the success of that boat getting out of the way of something is down? I think there's some parallels here. So what we did, we created this thing called MFOP. First let's go through open architecture. I'm backing up a little bit here. So also when I joined the Navy 2 years ago, I started looking at some of the things that they had defined as being, here's what open architecture is. And I'm not going to read these to you because the technical stuff's actually the easy stuff. So we kind of straightened them out. There were some things that were kind of left over from the old days. I encourage you to use these slides, and these need to get out to everybody, by the way. A couple things that we wanted to define: the operational interoperability and software system interoperability. These are also technical terms that most of the managers and other people don't have to worry about. The technical guys in the room will automatically get it. Okay, so I was at the Lockheed Martin facility working for Lockheed Martin at this time when we started this up on MFOP, and the first version went out, and it didn't really have all the features that we needed. But what we did is we took a rack of servers and we encapsulated those with some virtualization. And what that means is these servers were configured in such a manner that if one server failed all the functions of that server could rotate over to a backup, okay? So what that gave you was, it gave you the ability to survive a calamity, like a restart, or a hardware failure. The next part of the concept, they started on this Iwo Jima, a surface ship, in 2010, and this is one that my group in the Navy actually sponsored. And this is a case where we did the encapsulation piece, but we also included a way to phone home. Okay, and that is one of the critical pieces of IMPOP, is that there might be a case where a boat is stuck in the water somewhere, and from off board, someone can service that boat, help them get the system corrected, and be on their way. So that's the goal, is to keep people from being down, no matter where they are in the world. Then the next phase of this is, to take the system in such a way that at the right moment in time, when you come up with an upgrade to fix a problem, or to just upgrade the features, you could actually do that remotely. Would this be a nice feature for a cruise line, or for a ship like, or a boat, a pleasure boat like we're talking about, a yacht? I think it would. I think it'd be something that a person who was risking his life by putting it in the hands of a yacht would like to know that there's someone he could phone home to and they could fix it on the spot. Or every 2 years or so, he could also update it so that he's in the latest technology, because that's another one of the complaints we hear from the yacht industry. Okay, so we did this proof of concept demonstration. There's a system, I believe it's called CNI on the naval ships, and it's a little bit of a side system now because we have other things in the combat system. By the way, I work on combat systems, and we always describe it as things that make other things go kaboom. But this CNI is it's a common operating picture. What it does, it takes all the sensors on the ship, and it collates them together and builds you a nice picture where you can see where the bad guys are and you can see where the good guys are, and it gives you some sense of security knowing that you're not going to be in trouble in the next few minutes, somebody's shooting at you or something. So the system was installed on the Iwo Jima early in 2010. It was out there for, I think, 6 months on what they call a temp alt. And a temp alt is a situation where it's not a permanent part of the system. It's a way to test how the system is going to work when you put this in. And the only time we had any aberration was when we intentionally forced it to fail over. Okay, so here's the statistics on what was achieved. On the first 6 months, there was no failures, no hardware failures, no software failures. We had an IBM Blade Center that was configured with a virtualization that would allow us to fail over in case of any kind of fault. And the projection on this, the mean time between failure gave us a 91% or 99% capability to be completely operationally available. At 1 year, we ran the numbers. We were still at 99% based on the failure rates. At 4 years, we achieved 89%. This is statistically because we weren't allowed to stay on more than 6 months. But the good news is, the bad news is, the non-redundant system had a 48% availability. Okay, so that is significant with regards to any system. If you were driving your car and you knew that within 4 years it was only going to be available about half the time, you probably wouldn't buy that car. There we go. Okay, so this is kind of a depiction of how things flow to get open architecture MFOP installed or built up to the level where you can use it. The left-hand side, O to I, that's onboard spares or onboard fixes, to I, which is import fixes. Then the next level is the data collection level, where you've got the planning or the ability to predict failure before it actually occurs. And the third level is fault tolerance, and that's where you eliminate onboard repair parts, OBRPs, because you've already got them built into the system. You don't need manual repair because in the Navy we'd have somebody on board who was trained to be the repair person. You don't need that anymore. And you eliminate the maintenance training. So it's a huge saver and a huge security blanket for the commander on the ship to know that he's going to be, operationally available at least 99%, if not 100%. There we go. So here's what the system looks like. The goals over here on the right, and we kind of scrapped this together. I guess the point of this is that it's not the hardware, it's really the software that does the work. We've talked about this before, the software is invisible, but it's critical to do the system in such a way that you don't have to maintain it on board. The only maintenance that was done was they changed the air filters, okay? And when they failed over, they had to push one button to change the screen. Okay, here's some other cost savings. The tools and test equipment, maintenance manuals, like we said, replacement parts, drawings, all this stuff was 100% certified before we went on the ship. And they call it ILS, Integrated Logistics Systems. Normally, it takes years to get onto a ship because of all these things you have to test. So testing is not just the system, it's all the things that go with it. We had no problem. We went right on. It's a low-risk project. We use commercial stuff, and our Navy networks are really in good shape to handle this kind of stuff. So the idea of doing MFOP is something that's here now. And we're actually deploying it across the different systems as one of our open architecture initiatives. I'm just not getting real lucky with this device. Here we go. Let's go up a couple times. Okay, so it's all about total ownership cost. By reducing total ownership cost, we make the system more affordable. Budget pressures that we've got right now, especially in the U.S. Navy, DOD, we're going to have to save money. So this will be one of our strategies. Maybe I'll get you guys to go down. Kind of already said this. The next one. So this is kind of a block diagram. Some people like a little visual. It kind of shows you the way we used to kind of put things together on the left-hand side. And on the right-hand side, we're talking about how it really cuts out all this side stuff. The only thing that's new is the distance support. So you have to staff that. And that could actually be a business opportunity for someone who wanted to handle multiple yacht companies and provide that kind of service from anywhere in the world. Next. I'm going to give up on this. Next one. Okay, so you kind of see here the demo. We only had a server on board that was on the submarine that was encapsulated with the ability to fail over. In 2010, we included the network was able to fail over, the server and the storage and the display. And what we're working on now is to have everything, including the sensors, be able to fail over. So if you're using something that's commercial off the shelf, COTS, it's definitely a candidate. Next. Okay. You can phase this in. You don't have to do it all at once. In fact, I believe that the secret to success in our projects is to cut them up into small enough pieces where we can achieve them within 6 months. And even 6 months is kind of long. I mean, I don't know about you guys, but I like to finish up a project in 2 months. And then I'm ready to add on to it. So it really gives you a momentum for success. Next. Okay, we were going to put numbers on here, and this pitch is not my pitch. This was actually pitched to the Navy. But when they started looking for the statistics, no one's collecting data. And so I called up the guys at N41. That's the sponsor shop that actually writes the check to pay for this stuff. And I said, hey, I've got this great thing I want to show you how we can reduce your ILS to almost nothing. It'll save so much money for the Navy, you won't believe it. And by the way, each one of these dollar signs stands for a 0. So put a 1 in front of the minimum, and that tells you kind of the level of savings that we're achieving. Well, it turns out the N41 guys, they didn't want to hear about it because that was their job. Their job is to write checks, and our job is to spend it. And if you think about that, it's kind of retarded. I mean, you don't want to spend all the money. You want to save the money and give it back to the taxpayer, right? But that's just not the way we're motivated. Now, it turns out it's not that way in industry. In industry, you have a different set of constraints where people are looking for the best deal, and they'll only pay the best price in most cases, because that's what markets do. And that's where the marketplace helps us innovate, because people who adopt this are actually going to be in front of the people who don't. And that's what's going to happen across the board with open architecture and open systems and open innovation, all these things that we're trying to work on here. That's the way it works. Next. Okay, so I was at a small company in between Lockheed Martin and the Navy on this one, and I actually worked on some of this fleet tech assist data. And what this was is when we had a problem on a submarine, we would put a guy on an airplane and fly him a zillion miles. It would take a couple weeks, and so that meant the availability of that craft, of that ship to do a mission was out. And it was costing just a lot of money. So we put in this thing called the remote distance support. We got all the pieces put together where we could talk through the secure network. And by the way, in military parlance, it's a pain in the butt to get through all these networks. Got it all put together, but we saved a ton of money. So instead of the $15,390 for every problem, we were spending as little as an average of about $1,140. So it was a huge savings, 15 to 1. Next. Okay, this is a little bit of, for statistics people, a block diagram of how you kind of put the statistics together and how you have a feedback loop to figure out what you're doing. Next. Okay, so the goal for these systems with MFOP, and I think what the goal should be for pleasure yachts, should be that about every 4 years, should the owner want to, he can replace all of his systems. Because how many of you are using a PC that's over 4 years old? And if you've got one, do you like it? And if I'm a guy who's got enough money to buy a nice yacht, I'm under a couple constraints. Number one, Gear was telling me this, I want to make sure and keep it up to date because I might want to sell it. Nobody wants to come in and punch on a Commodore 64. I mean, we've got ships like that, you know. In the Navy, they're using old systems. Secondly, do you really want to pay for replacement parts? Because in order to find you a replacement part, a motherboard or something, the Navy has had to go to the extreme example of going to eBay and buying something off the shelf from somebody we don't even know. It's a terrible thing, but if it's the only way this system works and we don't have a new system to replace it, that's really bad. So the idea is we would have this system bolted to the deck plates, and after 4 years, it's still working good. It's only failed over a couple times. But you know what? We got another one we're going to replace it with, and it's got more features. It's more durable. It's got all the new stuff. It's faster. So we take this one off, forklift it out, forklift in the new one, drop it down, bolt it in, plug it in. We're ready to go. So that's the plan. It can be done on pleasure craft just as well. Next. Okay, so what's this about? It's about saving money. What saving money does in terms of the commercial industry is it creates a bigger marketplace. Because instead of selling 1 million yachts a year, maybe you sell 2 million. You increase the number of people that can reach this kind of marketplace. This is the kind of thing that changes your opinion about, am I too old to have a ship like this or a boat like this? Because I got to get to the doctor. And what if the boat breaks down? Well, if these boats are always available and they don't break down and all the systems on board can communicate, what new ways of leveraging those technologies can we come up with? And what new marketplaces are there for doctors to be anywhere in the world and come and drop in and help somebody? Or, it just gives so many opportunities for improving the operational capability of a ship like that and improving the safety. We've got terrorists, we've got pirates, we've got drug runners. There's a lot of worry out there. These kind of systems can overcome all that. Next. Okay, so my last little human behavior thing. I've worked on a lot of projects, and I've worked with guys like Gear, and I tell you, it's not about the rules. It's not about even the money. The environment's nice, by the way. If you have a good place, people will support you. But it's about the passion and the dedication of the people and the idea that you can do it quickly, the idea that you can deliver. It's about the art. It's about how you pull it together and your commitment to delivering. So, next. Okay, so the one thing that has to underpin this open architecture effort is a business model. And the U.S. Navy right now, our business model is broken. Nick and I have authored a white paper. I did all the work. He takes all the credit, and that's okay. But the point is, we are going to change the way we interact with our contractors. And we're going to put them in situations where they must compete between each other for different parts of the system. No longer are we going to sell systems or buy systems in such a way that it's all one company doing everything, because there's too much incentive to spend a lot of money. So we're going to put this down to a level where everybody, more small companies are playing in the business. Next. Okay, go to the last slide now. Can you go to the last one? Yeah, keep going. Last slide. All the way. More. Keep going. Up, one more up. Okay. Anyway, at the end of this slide presentation, there's a list of books that I recommend, and there's a couple notable ones. The first one especially, it's called Reinventing the Bazaar, A Natural History of Markets by John McMillan. Your group needs to think about how you're going to craft this marketplace, what you're going to do. And that book has more good ideas in it than any book I've found on marketing. Okay? That's all I've got. Any questions? At any time, I'm here today. Have to go back tomorrow. You're welcome to come up to me and talk. I apologize if I went pretty quick, but I'm open to any conversation. And thank you very much.
Okay. Thank you, Brian. We love to have you here. We actually said when we planned this conference that we need a reference case. We have an idea. We've done a lot of innovation. We have many owners supporting us in what we're trying to do for the yachting and the commercial industry. But of course, impossible is the word we hear very often. Well, I tend to believe